All right, so in the second lecture on the queue abstract data type, let us take a look at the programming exercise in which we are going to use the queue implementation that we finished in the previous lecture. Right? So recall that in the previous lecture, we looked at the queue abstract data type, we looked at the methods, we came up with an implementation, we compiled it, we made an object file, and we made the appropriate interface files. Right? So in today's lecture, we are going to take a look at this implementation, and we are going to use it in an interesting programming exercise. Let's go to the description of the programming exercise, and then let us go to the program and see the implementation and the execution of that particular program. So again, this is likely to be just a short lecture, approximately 20 to 25 minutes long, and most of it will be an analysis of the code that we have written. All right. So the exercise is to merge two sorted lists. Right? So this was the queue abstract data type. Now let us go directly to our problem. So the programming exercise is the following. You are given two sorted lists of integers, okay, and you have to output Q3 a queue with a merged list in sorted order. Okay. So you can imagine that there's a standard exercise that you might find in physical education classes in a school. You have two rows of students who are arranged in height order, and the physical education teacher ensures that the two rows are merged into a single row with all the students in the correct height order, in increasing order of height. This is something that most of us who have gone to school would have seen as a simple exercise. Right? So that's exactly our programming exercise. Right? So the first list is in Q1. It's a sorted list of integers. You can think of it as in ascending order. And the second one is again a sorted list. You can think of this as in ascending order. So now what we should do is, let's change it because I've written min here. The Q1 is in descending order and Q2 is in descending order, and the resulting queue should also be brought into descending order. Now let us just look at the pseudocode for this in terms of the functions that we have written. If the two queues are not empty, then you pick the front of the Q1, front of Q2, right? This is the peak front functions. Take the smallest of them, take them as next, right? Now keep index is equal to 1 if front of if next is front of Q1, right? Else index is 2. So now what do? We dequeue the next element from Q1 or Q2 appropriately and enqueue it into Q3. That is, we remove. This step only finds the minimum by probing into or peeking into the two queues. This sentence keeps track of which queue you peeked into, right? And this one dequeues from that queue, and this one inserts that element into Q3. Now if Q1 is empty and Q2 is non-empty, then what you do is you just enqueue by dequeuing from Q2 repeatedly till Q2 becomes empty. You enqueue into Q3. And if Q2 is empty and Q1 is non-empty, you repeatedly do the same thing by dequeuing from Q1 and entering it into Q3 and repeat it till Q1 is empty. So this was really this is the programming exercise, and we are going to, as you can see from the pseudocode itself, it's a crisp piece of code, right, where we essentially use the functions we have designed in the interface. Right? In the queue implementation, whatever methods we had implemented are exactly what is used, except for a min function kind of a thing that I have listed here. Now let's go to our program. Okay. This program is in merge.c. Right? I include interface.h. Let us look at the first method. It merges two sorted queues. Merge Q1 and Q2. What does it do? First, it creates a queue called Q3, whose capacity is Q1 capacity plus Q2 capacity. Right? Then what does it do? While the two queues are non-empty, right, if the element in the head of Q1 is smaller than the element in the head of Q2, you enqueue into Q3 the element at the head of Q1. Otherwise, you NQ into Q3 the element at the head of Q2 and remove it from Q1 and Q2 respectively. Otherwise, while Q1 is not empty, you put all the remaining elements into Q1. Otherwise, you put all the elements of Q2 into the Q3 and return Q3. This is exactly the pseudocode that we had seen. Okay. Then we have a print function. The print function is also interesting because it is a use of the deq function. Right? So it takes q as an argument, and while the queue is not empty, it prints the elements of the queue one after the other. Now let us just look at the main function. Right? Main function is written in such a way so that you can get a flavor of the utilization of all the different methods that we have implemented. Right? The first statement is to create Q1 with 6 elements. Right? Now observe that the 6 is not very important. You could have actually put a scanf here, read the value of the queue and then created this queue, which is perfectly fine, but that's not what I have done because I just want to show you the utilization of this queue. Now you have Q2. Right? Now you create queue with 7 elements, and because we are doing a circular queue implementation in our code, right, we have used one more location than what is required. Now we have a pointer for Q3. Right? Okay. So now you do the following sequence of NQs. You NQ 1 into Q1, then 3 into Q1, 5 into Q1, 7 into Q1, and 9 into Q1. This is just done just to make illustrate the concept that you can essentially enqueue a sequence of elements, and you can even encode this by interacting with the user and putting the elements into a loop. Then you enqueue into Q2 the elements 2, 4, 6, 8, 10 and 11. So observe that in one queue we have only 6 elements, in the second queue we have only 5 elements. That is, in Q1 we have 5 elements and in Q2 we have only 6 elements. Now we merge the two queues and we print out Q3. Right? So of course there are other methods that I am not showing you. I am not checking whether the queue is full and so on and so forth, but is empty is being checked. Of course here I should have checked if the queue is full or not, but since it's just a toy example, I have not checked if the queue is full. That's a toy merge program, right? To merge two fixed queues, just to show you the example, but it's very easily modifiable by interacting with the user, right, who runs the program. So let's compile merge.c. And you will recall that one has to include into this compilation or link it with the object file that we have. Otherwise the compilation will fail. Now let us see what happens if I leave out that. As you can see what it says, right? It compiles, but then it says that it cannot understand the symbols create queue. It cannot understand DQ, it cannot understand NQ, it can't understand is empty, it can't understand peak front, etc. In the earlier lectures I did not show this to you, but now I've deliberately made an error by not including the object file or linking the object file during the compilation, and you can see that the compilation fails to recognize these particular functions. Though the compilation did not have any errors, right? It says that you must read the message very carefully. It says that in the function merge, create queue was not understood. In the function merge, DQ was not understood, and so on and so forth, also in main. So look at this error. It says linker command failed with exit code 1. Right? So it says that it was unable to link these particular functions, right, which are available in the header file. Right? Now let's solve the problem by linking QArray.o. Right? Now the compilation has succeeded. Now I have the merge program. As you can see, the merge program has merged the two arrays into a single array in ascending order. Right? So this is really treated as a queue. Right? So as you can see, all the queue methods were used to merge the two queues which were there. Recall that one queue had 1, 3, 5, 7, 9. The second queue had 2, 4, 6, 8, 10 and 11. And observe that both the queues have been merged into ascending order. So this really is a very simple, but many of you who know this merging procedure, right, would have seen it as a very important thing in sorting algorithms like merge sort, which are recursive sorting algorithms. Right? So what we have done is we have implemented a very quick merge using the queue abstract data type. So as you can see, the code is very crisp and very easy to build from the different individual functions which we have designed and implemented with the queue abstract data type, to the extent that the merging program is almost exactly what you see in the presentation. There is absolutely nothing new except for this create queue function, and then we already saw this loop which was there. And the most important thing is that this way of programming ensures that if you make a good presentation and if you understand your functions clearly, then writing a program is extremely simple. Therefore, whenever you use an abstract data type, it is very important for you to define the data type completely and then use it in your implementations. This is a very important message. This completes the utilization of the queue abstract data type in a very important programming exercise. You will get a similar programming exercise for you to program, right, in this week itself. Right? It will be fairly challenging and we will come to it by tomorrow. Right? In the next lecture, what we will do is we will look at the different types of queues. Right? This is a very fundamental difference between stacks and queues. There is only a single type of a stack, but there are multiple types of queues that you would want to maintain. And we will see what kind of queues are there and why they are important. And let us just continue on to that particular presentation itself. Alright, so let us just look at the different types of queues which are there. Okay. So this is the queue abstract data type. I do not have to go back and say point out what are all the different data items which are maintained in the data type and what are all the different methods. We have seen it. Right? There's enqueue, dequeue, there is peek front, there is isEmpty, isFull, there is size. These are all the methods. And the data items are the array that contains the queue and so on and so forth. What are the different types of queues? As you saw, the implementation of the queue was actually of a circular queue. Now, it is important for you not to get confused that a circular queue, right, is a special type of a queue. A circular queue is actually a circular array implementation of the queue abstract data type. I repeat, the circular queue is nothing else but a different implementation of the queue data type. Right? What do I mean by this? The circular queue does not provide the user any new specific features because of it being a circular queue. Right? It only provides you an efficient utilization of the array space, right, to maintain the queue. Right? And the enqueue operation incremented the rear by 1 modulo n, right? And the dequeue operation incremented front by 1 modulo n. The queue was empty if rear is equal to front, and if it was full if rear and front differ by 1. Right? And it is a better utilization of the available array implementation. Right? It's a better utilization of the available array in this particular implementation. So therefore, we have a special kind of an implementation of the queue data type, which is the circular queue. Sometimes it is also called a ring buffer. There is another queue which is called the double-ended queue. Right? We will come to this queue a little while later. A double-ended queue is otherwise called a D queue or a deck. You insert and delete from either end. The importance of this queue will become clear when you think of the following question, that in normal queues people enter the queue and decide to actually exit from the queue, at which point of time they just leave the queue from wherever they were. Therefore, while we should be able to insert into the rear end of the queue, we should also be able to allow people to exit from the rear end of the queue. So this is what a double-ended queue is, where we would like to insert and delete elements from either end of the queue. Another very important queue is what is called a priority queue. And priority queues, as the name suggests, is not just a queue in which the elements are organized in a first in first out fashion. Every element has a certain priority. So clearly, I mean, if a certain very important person arrives on a road, then such a person gets a higher priority to use a road, and everybody else is arranged, right, to stand and wait for this higher priority person to go ahead in the queue. Right? But while this person goes ahead in the queue, the remaining people with the same priority have the same relative positions in the queue. Right? So this kind of a feature is definitely provided by the priority queue. That is, it is a queue first of all, which means elements are n-queued and d-queued, but the items can be ordered by certain additional values called priorities. Element with the lowest key value has the highest priority, and this one is always to be at the front. That is, the element of the highest priority will always be at the front of the queue. Therefore, what are all the things that we must do? Enqueue function has to be modified. If we insert an element into the queue that is at the rear of the queue and it has the highest priority, it must somehow be ensured that it comes to the front of the queue, and all other positions must be readjusted. Very importantly, it must be readjusted quickly. Similarly, if you want to dequeue, that is, if you want to remove an element from the queue, then you must modify it so that you get the element of the least value, in other words, the element of the highest priority, and then the next element must be organized so that the next minimum can be obtained very quickly. Right? So this is a dequeue operation. Right? So you can again imagine that if somebody has a higher priority, such a person must be brought out of the queue first, and the next person or the next data item which has the best priority or the highest priority must be arranged so that it can be removed quickly when the time arises for that element to be removed. The other operations are that you might want to update the priority of an element based on certain things. Right? So those of you who are studying operating systems, right, or who have some exposure to operating systems will recall that priority queues play a very important role, and changing the priority of a element is a very important operation done by the operating system. So there are two ways of implementing the priority queues. Right? So let us just look at the methods. Right? There are enqueue and dequeue to be modified. We must also have an additional method. Right? So in this sense, a priority queue is very different from a circular queue implementation of the queue itself, right, or the circular array implementation, because it provides an additional method where the priority value or the key value of an element in the queue can be changed. How do we implement priority queues? There are two ways of implementing priority queues. One is that you can implement it in an unsorted list. For example, let us just look at this. If this is the queue, 4 is at the head of the queue, 5 is at the next element of the queue, 2 then, and 1 is at the last place. Then whenever we want to insert, you just insert them at the beginning or the end of this particular sequence. That should not be very hard. But remove min or finding out the element of the least priority will essentially require us to traverse the whole list and find out the element of least priority. Therefore, to identify the element of the least priority can take as much as the time taken to traverse the whole list. Right? So imagine that if you have a queue of 1,000 people and you have to pick the person with the highest priority, then you have to inspect 1,000 people's priorities before you pick them from the queue or pick them from this unsorted list. If you perform an implementation with a sorted list, then whenever you want the element of the higher priority, you can immediately remove it in order of one time. You can immediately remove the element from the appropriate end. But whenever you have to insert an element, you will have to go through the whole list and find the correct place to insert the element into. The same is true with when you want to change the priority of elements. Whenever you want to change the priority of the elements, you will have to actually do quite a bit of work by inspecting each element, changing the priority, and then reorganizing the list. Where are priority queues used? The priority queues are used in what are called round-robin schedulers. Okay. In a round-robin scheduler, you dequeue the element. This element has the highest priority. And while that element is being serviced, right, the priority of the other elements keeps increasing over a period of time. And after a certain amount of time, if the service of the element has been completed, it goes out of the queue. Otherwise, it enters back into the queue with the least priority. In the meanwhile, the priority of the other elements have increased. Among these, you pick the element of the highest priority and then service. Therefore, these are called round-robin schedulers, right? So service, you are scheduling the elements in this queue to be serviced here. You can imagine this to be a CPU, and these are the processors managed by an operating system. Right? So round-robin schedulers are extremely popular schedulers. Where do you find queues used? Like I was just saying, queues are used in process scheduling. That is in a multi-programming environment where there is a single processor and multiple processes waiting to be executed. Then multi-programming provides each process the illusion of being a single process using the CPU. So process scheduling extensively uses the concept of queues and priority queues. Similarly, printer queues and keystroke queues are essentially hardware queues that are maintained. Right? For example, if you send a set of jobs to the printer, then to be printed, then they are all printed in the order in which they have arrived at the queue. Queues also form an auxiliary data structure for different algorithms. In one of the upcoming assignments, you will be implementing queues. Right? And priority queues are used in efficient implementations of many algorithms. And we will study the implementation of a priority queue in about 2 weeks' time. That will be in your penultimate week of lectures for this online course. Right? So this brings to an end this whole discussion, the sequence of 3 lectures, right, on queues. Of course, 2 of the lectures were merged into one so that you have a single solid lecture to look into. Right? So we looked at the vanilla queue abstract data type. We came up with a circular queue implementation. We used this circular queue implementation in a merging program. Merging program is not just some ordinary program. It is used in recursive sorting algorithms like merge sort. And then we looked at the different types of queues which are available and what their different purposes are. In subsequent lectures, we will move towards nonlinear data types like trees and heaps, and then using heaps, we will implement priority queues. Right? We will definitely look at more implementations, and this brings to an end this week's lecture on the queues. Initially, I had planned that it will be 3 lectures, but I have merged it into 2 lectures which will be uploaded. Enjoy these lectures, and I look forward to your comments and questions. Also look forward for the next programming assignment in a short while. Thank you.